Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So, I have shown you previously how we can go ahead and use the Java applet method and the PDF file Trojan horses. But in this tutorial, I will be teaching you something different, that is man in the middle attack, or it's also called as monkey in the middle attack. So what you to be more precise, in short, what you're doing is that there are two computers and you are sitting in between their connection, and whatever passes in between them you are sniffing, modifying, changing, or poisoning all of these cache memories, or not only cache memories, also the active bits that are being transferred. So that's how it works, but there are different ways as to how we can go ahead and do that. And this is a simple way as to how we can go ahead and do that. This is the server, this is the client. The client tries to access the server, but you are sitting in between, and most of the time this happens in public Wi-Fi hotspots. So let's say, for example, this is a McDonald's and this is you are trying to use the open server of McDonald's, that is the Wi-Fi hotspot that they have, which is most of the time open, and this is the attacker, that is me sitting over here. So when you try to go ahead and log in on the McDonald's Wi-Fi hotspot, you are sending the information, but the information is not directly going over there. It's being transmitted to me, and then I can go ahead and redirect it with where I want, or I can go ahead and poison it and send something else to the server. And then if the server sends something, I can go ahead and modify that again and send it back to you. So I'm just sitting in between, and I am going ahead and doing all the changes that I need. But there are different ways of attacks, and there are multiple types of attacks which we can do, because when you go and try to connect to your client, there are multiple things happening in the background, like gathering DNS information or the ARPs and multiple other things. So these are the different types of attacks that are there in man in the middle attack. That is local area network. That means it's just on. It's not on the internet. It's just between inside the company. It can be like, you can say, as the intranet, for example. So these are different types of attack, that is ARP poisoning, DNS spoofing, STP mangling, and port stealing. And then we have through a gateway from local machine to a remote machine. They're doing the same thing again: ARP poisoning, DNS spoofing, DHCP spoofing, ICMP redirection, IRDP spoofing, and route mangling. And finally, once we have the remote access, we can again go and do DNS poisoning, traffic tunneling, and route mangling finally. So I would be teaching you some of these stuffs today, and I'll let you know how exactly these works. So we will start today with ARP poisoning, and I'll tell you how this works exactly. This is how an ARP poisoning works. The user is connected to the client and you are in between, so you know what's happening exactly between the user and the server, and the actual data that you pass is never reaches the server. It goes through you and then it reaches server, and whatever the server reply, and you know what exactly is happening. So whatever you are trying to send, the attacker can go and modify and send something else, and send something else back to you. So for example, if you go and try to access youtube.com, the attacker will go ahead and redirect that traffic to, let's say, for example, any random website, let's say wonderhowto.com or google.com, for example. So it doesn't matter how much time you go and try to visit Google, it will still redirect you to google.com, because it is the attacker what is happening. Or if it's trying to access facebook.com, it doesn't matter even if it's through HTTPS website, the person can still go ahead and gain access through that by going ahead and stripping off the SSL from your, that is the security from your 128-bit encrypt. So that's how it works. So let's start with what ARP poisoning is and ARP spoofing is exactly. So you may not be knowing what ARP spoofing is exactly, so I'll just go ahead and define that for you in simple terms. The full form of ARP is Address Resolution Protocol, and ARP protocol is something different, and let me tell you that there are two different things. If you go and search on web, that is ARP poisoning and ARP spoofing. They're almost the same, or I can say that not exactly the same, but one is a part of the other. That means ARP spoofing is a part of ARP poisoning. So that means if you are poisoning the ARP, then spoofing is automatically happening in the background. So as you can see, we have two computers. One is the original computer. This is the server through which it goes, and I am the attacker over here. And this is the HP laser printer jet, and this as the IP address. So ARP is a protocol for mapping an internet protocol address, that's IP address, to a physical machine. So it goes ahead and gives a specific IP address to a physical machine, and it is recognized in only the local area network. For example, in IPv4 version, the most common level of IP in use today, an address is 32 bits long. And in Ethernet or local area network, the address, however, for attached devices are 48 bits long, and the physical machine is also known as the media access control or the MAC address. And a table, which is usually called as the ARP cache memory, is used to maintain a correlation between each MAC addresses and the corresponding IP addresses. ARP provides the protocol rules for making this correlation and providing addresses conversion in both directions. So when an incoming packet destined for, let's say, a host machine on a particular local area network arrives at a gateway, the gateway asks the program to find a physical host or MAC address that matches the IP address. So as you can see in the diagram over here, it's asking that who has the IP address of 192.168.0.45. It's asking either of these three computers, because these three are the LAN connection right now. So, and the ARP program looks in the ARP cache memory then, and if it finds the address, it provides it so that the packet can be converted to the right packet length, that is 32-bit or 48-bit, whichever it is, and format it and send it back to the machine. If no entry is found for the IP address, ARP broadcasts request packet in a special format to all the machines on the LAN to see if one machine knows that it has that IP address associated with it, and the machine will then automatically go ahead and contact back to the originating machine. And the machine that recognizes the IP address as its own returns a reply, so indicating the same. And ARP updates the ARP cache for future reference first, and then sends the packet to the MAC address that replied. So you might be wondering, what is ARP poisoning exactly? So it is that, to be in simple terms, normal hackers lie, and skillful hackers lie very well. And the hackers that are well-rounded, they can lie both to machines as well as people. Lying to people is known as social engineering, and it involves tactics which was detailed at length by convicted hacker Kevin Mitnick, such as posing as a company's employee so that the company's real employees will blab all their secrets freely. But lying to machine involves lots of different techniques, and one of the most commonly used one is ARP cache poisoning, and that is the focus of this tutorial. ARP poisoning enables local hackers to cause general networking mayhem because it's mostly incurable, and every administrator should be aware of how this works. ARP is basically a form of networking roll call. It is a very simple protocol which consists of merely four basic messages. The first is that at the ARP request, computer A asks the network who has this IP address, and ARP reply, as you can see on the diagram over here, that this is my MAC IP address. And then a reverse request by ARP, that is RARP, that is called as, and it is the same concept as the ARP request, but over here the computer A, that is the Jessica's computer over here, it replies who has this MAC address after they have the IP address, and then the computer HP LaserJet printer replies that it has the MAC address. So first it checks the IP address, then it checks the MAC address. So all network devices have an ARP table, a short-term memory of all the IP addresses and MAC addresses, and the device has already matched together. The ARP table ensures that the device doesn't have to repeat the ARP request for the devices it has already communicated with. So here's an example. I'll go ahead and teach you of a normal ARP communication about the Jessica and the HP LaserJet printer, which I will be teaching you today. So, but that is it for this tutorial, guys. Which I was about to tell you as to how ARP works. In the next tutorial, I'll be teaching you in detail as to how this works exactly, along with an example. And later on, we would be trying that, and after that, we will go ahead and inject our main viruses inside our software payload, for which we would obviously be needing the EtherCap, which is again takes back to the MITM, that is man in the middle attack. So that is it for this tutorial.